Welcome to Mainly AI, where we explore artificial intelligence, emerging technology, and what it means for business and everyday life, with your host, Dan Mitchell.
Welcome back to Mainly AI. I'm your host, Dan Mitchell, and today we're diving into a side of artificial intelligence that doesn't get nearly enough attention. While much of the industry is focused on building larger models and chasing the next breakthrough capability, today's guest is focused on a different question. How do we make AI practical, efficient, and economically viable at scale? Joining me today is Manya Gabati, Associate Professor at MIT's Computer Science and Artificial Intelligence Laboratory, or CSAIL. She's the founder and CEO of Systalize, and a researcher whose work spans AI systems, cloud infrastructure, networking, and machine learning efficiency. And before joining MIT, Manya worked at both Google and Microsoft Research. And today, she sits at a unique intersection of academia, entrepreneurship, and enterprise AI. Manya, welcome to Mainly AI.
Thank you for having me.
Absolutely. So you once told me that models are just math, and that statement has stuck with me. What do you mean when you say models are just math?
The way I think about AI models is different than the good old database systems. The complexity of a database query is determined based on what the operation this query requires, if it's a simple select or if it's a joint operation. To me, AI is flipping that. The complexity of an AI prompt is actually not dictated by what is the prompt, it's actually what AI model that prompt is going through. So think of it like this. Who is the president of the United States versus what is the solution of this differential equation? If they go through the same model, they are going through the same architecture. They're going to go through the same mathematical matrix multiplications. And so to me, AI is just math is because AI is dictated by the architecture. Underneath those architectures is a series of algebra, mostly dominated by matrix multiplication. And so it's almost like a flip in the world of old systems versus new systems, where before the complexity of the prompt or the query would determine how long this query is going to take. Whereas here is the complexity of the underlying AI model that's going to determine how long this query is going to take. This is very loose, but this is sort of foundationally accurate.
Okay, so for someone who uses something like a ChatGPT or a Claude every day, what's a simple mental model that they can think about for how an LLM works in the first place?
Mhm. LLMs are basically predicting a next token, or let's be more precise, the probability of what the next token should be based on all the previous tokens. And so you've probably seen that when you type something in ChatGPT, it's just typing like word after word. It actually is predicting token after token. And a token is basically a series of characters, like say 3 to 4 characters. It's not actually a word. We do see words and we speak in words, but for an LLM, it's all about a token. This is the unit that the model is basically predicting. So ChatGPT or Claude, the way they work is given a series of previous tokens, let's say the cat would like to go to, then there would be a series of predictions and the probabilities associated with them. A box, the fence, red, book, and then probabilities. The word or the token with the highest probability would be predicted as the next token. The cat would like to go to the box. Maybe box has the highest probability. Then that becomes the next context, we call it. And then the LLM would predict the next token and the next token and the next token. So it's a probability of what would be the next token given the set of previous tokens.
Got it. Thanks for that. Yeah, a lot of us take it for granted that it just works. So if AI is ultimately math, then every interaction requires computation, right? So
Mhm.
is that where the economics of AI begins?
Precisely. So how do you do these predictions? We said matrix multiplications and some mathematical optimization functions. Okay. GPU is now the perfect architecture, the perfect hardware, because it was originally designed for gaming. And in gaming, you also have a lot of matrix multiplications. And so it just happens that this is a perfect hardware for this particular, we call it a workload. And so, yes, what drives the economy and the cost of when you type something into ChatGPT and you get charged is on where is the model. The model sits on a bunch of GPUs, and these GPUs are expensive, but they're performing the mathematical matrix multiplications very quickly for you.
So, we spent the last few years talking about AI capabilities, right? This one can code, this one can make images, right? But it feels like now we're talking about AI economics, and you hear people use the term tokenomics. Are we entering an era where efficiency matters as much as the intelligence?
I would argue that efficiency already matters. We should think about efficiency from day one. I've heard tokenomics before. It is an artifact of the charging mechanism that frontier labs have invented. Token pricing. Think about it. Why are we paying per token? Why aren't we paying per request? Why aren't we paying per number of GPUs? What drives this concept of if the LLM model generated 20 tokens, I should be paying 20 tokens worth to a model provider? What if the model is not clever and it takes multiple prompts for the model and multiple responses for the model to reach this high quality response to me? Why should I be paying that? So I think we should have started thinking about efficiency from day one. And we shouldn't necessarily submit to this notion of everything should be measured by tokens and everything should be priced by tokens. Even if you put that on the side, even if we accept with the token pricing is the right way of advancing AI to the next level and having everybody on the planet to use AI, there is not enough resources for the entire world to be using AI and embedding AI into our day-to-day tasks without really even thinking about optimizations as first principles. Right now, the GPUs, there's shortage on hardware. There's new models that are coming every day, new use cases. If we don't even think about efficiency right now, we're already losing the AI game.
That makes sense. Talking to different leaders about their token economics. Normally, they just point at their API bill, right? And usually they've got a kind of overwhelmed look on their face when they do that. And it's part of like that bigger picture of how do you get AI and be able to do the ROI. So as part of building your research and building your company, you talk to a ton of people about the problems they were having trying to solve with AI, right? And so organizations have invested heavily in AI infrastructure, especially as an alternative to the endless consumption of these frontier model tokens in the cloud. How do they know they're getting the most value from those investments that they've made?
The sad reality is that they don't. And I want to solve that. That's a very deep research interest for me on given a particular use case. Let's say an internal ChatGPT. There's an organization that is interested in building an internal ChatGPT system for themselves or a document processing system. What should be the investment on AI and what would be the expected return of investment? It seems to me right now that we don't know. I've had more than 1,000 conversations with AI leads across many, many Fortune 500 companies. And you're right. Everybody starts by saying, yes, we have a subscription to Anthropic and to OpenAI, and the bill is coming, and hopefully it's going to do something for us. Every day, the bill can grow, and as more employees adopt the tools, and then they start thinking, actually, maybe we should have a cap per employee. And that's actually already sort of defeats the purpose of using AI company-wide. So I'm completely against this way of innovating with AI. The way I think we should have started with AI is, let's deploy AI models and let's charge based on the GPUs, that unit that is performing the compute. And so let's embrace open source models. Let's ditch token pricing. It's not really a good model. It just doesn't give you a way of measuring what is expected. The model can go crazy. And hasn't it happened to you? It happens to me that the model is just going crazy and it's just like, and I'm like, end, don't even produce more tokens, don't want you anymore. That just doesn't make any sense to me. At a large enterprise scale, there should be self-hosting open source models and being able to leverage all of these open source models and not even thinking about token pricing, just thinking about how many GPUs do I need? Maybe the GPUs are available through cloud providers. Maybe the GPUs are available through an AI factory. So obtain the GPUs, understand what is the required number of GPUs for a particular task, and then you have a deterministic price. You have a deterministic performance. That's what we are trying to do at Systalize. We're trying to bring the mathematics back to the calculations and say, given a particular use case and given a particular hardware, what would be the expected performance, how long it's going to take for this particular model to be producing a response on this hardware. Like I said, the hardware can be in an AI factory, the hardware can be in cloud, the hardware can be in somebody else, your neighbor's house. That doesn't matter. What matters is to be able to enable these enterprises to think in a very rigorous way of, here's what I would like to do, here's the required hardware, hence this is the amount of money and investment that I need to put into this one use case.
Yeah, I think a little bit about the airline industry. They own these planes, and owning the planes is not enough. Their profitability is centered around how effectively those planes are used, how many people are on every flight. But it sounds like AI is just not there. They don't have it down to a science yet, and they're still trying to figure it out.
Yes, it's almost like we're all chasing the dragon here and we get distracted by it. We look at, okay, there's this new model and it's like $27 per million tokens, it's okay. There is no evidence that if a model generates more token, it means the model is more intelligent. And we should separate those things. It's very, very important to think about AI model from a capability perspective, not from how much garbage or how much tokens they're generating.
Yeah, it's definitely a good perspective. You wouldn't just pay somebody to do a lousy job if they were working at your house and they just continued to bill hours for doing repairs and didn't do a good job. So, yeah, I think that figuring out how to hold models accountable for their quality and efficiency is an important step.
And that
So-
goes back to the math.
Yep.
Because a bigger model performs more mathematical computations than a smaller model. So it is possible to argue and say, if this model is performing more mathematical calculations, more matrix multiplications, then you should be paying more because under the hood, you would be needing bigger GPUs. So there is a way to connect these by thinking about the underlying resources required to execute this particular model. So these are loosely connected, but simplifying it simply to the number of tokens that have been generated is a little bit of a disservice to the users.
Got it. Okay. Well, changing gears a little bit, you're in a unique position, as I mentioned earlier, and you're seeing frontier research, you're talking to your startup customers, you're with MIT students all the time. Who's moving faster right now, academia or industry?
Perhaps the best way to think about your question is there's probably two sides of your question. One is maybe think about where AI was generated to begin with. Who came up with, let's say, the original ideas behind AI? And so maybe longer term ideas, academia is still a better place to innovate from that perspective. Right now, LLMs are the dominating AI conversation. But maybe not. Maybe LLM is not really the ultimate architecture or type of models that we're going to use for AI in the next decade. What would be that next jump in technology or architecture or design? That's probably going to come from academia.
Mm.
But because LLMs are very large and running them requires a lot of resources, and academia does not have those massive resources of GPUs, back to our conversation on the economy, industry is making a lot of progress on larger scale experiments and observations. And there should be a world when we are managing and merging these two efforts together. And there's a lot of initiatives around this. But
Sure.
to me, it's almost like most immediate innovations and most immediate observations that would lead into innovations are coming from industry. And my colleagues in various industries are even publishing. So they're contributing to the community. But I think that next generation, next jump in technology is likely to come from academia.
Got it. Yeah. A lot of academic research never becomes a company, right? And your startup is a culmination of multiple years of research. So, what was the hardest part of making that transition? And was there a moment when you knew Systolize was solving a business problem and not just a technical one?
Good question. It came to me somewhere in just a couple of years ago when I realized that even my students are sometimes struggling with keeping an AI model up to date and always running and always highly efficient and performant in our lab inside MIT. So a little bit of backstory. I have a couple of GPUs, some number of GPUs at MIT for our research because our research is about optimizing and efficient AI systems. And every time that we would write a paper, we would bring up the system, we would run experiments, and then some other student will just take over the test bed. And it turns out that between, like, even within a few weeks of running this particular experiment, switching to another experiment, or then a new model is released or new library is released, I noticed that even my students, who are the top of the echelon, would sometimes struggle of keeping this test bed
Mm.
highly efficient. And we continuously have to maintain this. That, coupled with a series of conversations with members of the CSAIL community called CSAIL Alliances, where we presented some of our ideas and some of these pain points. And there were AI leads that were already thinking about maintaining their own on-prem or cloud GPU clusters. And they were sharing the same pain points that every time that there's a new model, every time there's a new library, every time that there's a new, even open source tool, it takes a while to put everything together and to make sure that the solution that I have created right now on these GPUs and this GPU cluster is actually as efficient as it can be. And so it was realizing a pain point that I've seen internally in my group and then validating it with some early adopters.
Got it. Cool. Cool. I love it. So, so I guess one question I have for you, how do you personally stay current when AI is evolving so quickly? What is your secret resource? Where do you collect as much information and learn as much as possible?
I'm constantly worried about falling behind, and it's almost humanly impossible to read every blog post, every archive paper, all of these conference papers. There's so many breakthroughs that don't think I'm at the, I don't think I'm every day, I know exactly what's going on. My secret weapon is that I'm lucky that I have smart students. And it's almost like you're parallelizing your effort of staying on top of the knowledge base. So I think I'm a few days behind. I still have to have the students to absorb what's going on, and then the students filter the key ideas. And then through communications with the students is where I oftentimes find out about there's this new technique that was just proposed, or there's this new model. Did you hear that? Like, say 9 a.m., there's a new model that is released. I'm probably in meetings. But then around noon or lunchtime, have a conversation. And then I'm lucky that I get that information very quickly through students.
So, speaking of those students, what do MIT students understand about AI that enterprise leaders may be underestimating?
Probably it has something to do around the capabilities of the models and the opportunities on optimization. Oftentimes, industry leaders tend to accept that here's the model and here's the price and here's how it operates. Whereas the students, or in my case, it's a combination of my students and my amazing engineers at Systalize. I should add, most of them are former MIT students or current even MIT students. So I think the younger generation doesn't necessarily accept the status quo, whereas an enterprise leader often probably is busy leading that business. And so they would accept that, okay, I guess this is how this model runs, and I guess it requires this many resources, and I guess this is the price. Let's figure out how to build a business around it. Whereas engineers and students would start by saying, why? Is there a way for me to make it better?
Great. Great. Well, there's a lesson for the enterprise leaders who are listening. Take a lesson from some MIT students. So let's get to industry. What would you say is the most overhyped AI trend right now, 2026? What is the most overhyped AI trend?
And by overhyped, you mean it probably does not deserve to be overhyped? I hesitate to make a precise prediction at the fear of what if in a year that becomes the next big jump in technology. But maybe I can talk about some of the directions that I often hear about that perhaps should be more grounded. One is agentic AI, where everybody talks about agentic AI and it's like overpowering all of our conversations. And I think it's going to change the way that we're thinking about the world. I have no doubt about that. But the details, like if you ground the word agentic and if you actually think about what is every conversation, what are we even talking about when we say, let's agentify this application? I think there's a lot of nuances there that sometimes even a simple Python script that's automating a process that has nothing to do with AI could be advertised as here's the new agentic workflow. And I think that's where maybe the fallacy is, to embrace the technology, embrace the potential, but also don't forget and be a little bit more precise about when we say agentic, what are we actually talking about? Is it possible to overhype it and say, maybe Dan, this conversation is also an agentic conversation because you are having an AI companion taking notes. And so you and I can go and advertise this conversation as we just had a fully agentic podcast. I think that would be a little bit of overhype,
I
right?
agree that agentic AI is definitely on the buzzword bingo card, probably the free space in the middle, if I were to qualify it as how much it's overused today in the industry and in the terminology. And to that end, I would say that people are using it more for marketing, and there are a smaller percentage of people who can actually deliver AI agents. But such is the hype cycle, right? It'll eventually come back down. People have already moved on to everything claw, so agentic will get grounded. But on the
Mhm.
inverse of that, what is the most underestimated AI trend that we should be looking at? You know, the kind of break the news. You heard it here first from Manya. What is the underestimated AI trend that's coming?
Let me think about that. There's many.
Well, you can pick 3 if you want. That's fine too.
I think something that has been overlooked, and I can say that with certain level of certainty because I've spent the last 8 years of my life thinking about this, is how much work can be done with the current available resources. So the trend is often more is better. The more money you spend on AI is better. But I think what's being overlooked is the capabilities that we have today and the power that we have today can achieve more than what we are doing. And maybe this connects us to the performance optimization. I don't think it's overlooked, but I think it should be widely adopted. There are papers that we see once in a while, there's efforts that we see once in a while, but the fact of the matter is oftentimes back to the chasing the dragon. I think it gets, maybe energy efficiency is a better term of putting here. It's like performance efficiency and energy efficiencies. And it is somewhat, people are worried about energy, people are worried about performance, but it oftentimes becomes the second part of the conversation sometimes. And I think that type of conversation, that type of mentality has to change. There isn't enough power in the world to enable agentifying all of our applications.
Yeah, for sure. For sure.
But also there is, if we actually think about, there is room to optimize and there is room to pack. There is resources. And I think there is a way for us to actually double the capabilities of the current power plants by packing more work into the GPUs, by optimizing the way that we are building these solutions. So if we continue doing the way we're doing things, there isn't any, we're almost doomed. But if we actually think about optimization as a first principle and bringing that into every application that we're building, every AI model that's running, if we change the pricing model into related to the optimization, related to resources, I think that opens up the routes that it's impossible right now.
Okay. Well, let's hope that we're able to go that way. I'll double down on a prediction ask here. So you've spent your career studying the systems that power modern computing and AI. If we sit down again 5 years from now, what's one thing about today's AI landscape that you think we'll look back and we'll say, I can't believe we used to do it that way?
A lot has changed, actually. Maybe I answered from an academic perspective and then from a business perspective. Academic perspective, I already said, I can't believe I used to write every word of every paper. I used to generate every plot manually with PowerPoint or with Excel. I can't believe I used to do that. I can't believe I used to, every slide, I actually used to build everything, write everything, every word was generated by a person. So that's already happened. But let's extend that to the rest of our lives. Still right now, you and I write emails to each other. We write text to each other. I think all of that is going to be gone. Purchasing, a lot of decision making, a lot of perhaps hopefully mundane decision making that could have been automated. You and I are going to look back and be like, I can't believe we would be typing text to each other, or we would be sending each other documentations or designs, or all of that is hopefully going to be taken by, let's use the hyped word of agents. A lot of our tasks. And hopefully you and I would do the creative tasks. Right now, probably during the day, we're doing some creative work and some mundane, repetitive work that can be automated. And I'm hoping that in the future, in 5 years, agents are taking care of the repetitive work, and you and I only have the creative component of our days. And we expand that and look back and say, oh my God, I can't believe that I was wasting my time responding to emails that could have been generated automatically, or scheduling things on calendar, or building slide decks.
I believe it. I believe it 100%. As someone who formerly owned a flip phone and then came with predictive text, and that was wonderful. And then came the ability to type on a keyboard on a phone, and then autocorrect, which is a love-hate relationship for me, right? Sometimes you don't want to use the word duck, but it autocorrects to it anyway. And so let's hope that you're right, that efficiency of all the mundane tasks just goes away. No more mundane tasks, just focus on creativity and thinking about new ideas. Well, finally, if listeners take away one thing from our conversation today, what do you hope that is?
I would like to encourage the listeners to challenge the status quo. If you are an actual AI user, challenge the status quo more. Be hungry on the use of AI, but also be observant and keep asking, why is it done this way? Why am I choosing this particular model? Why am I going to this particular provider? As opposed to following the herd of today there's a new model and everybody should use it, or my friend told me about this one feature or one service that I should use it. I think AI is moving so fast that it's very hard for all of us to sit back, think deeply. And if there is one thing that I would like to encourage the listeners to do is take a moment and think about AI and how it can help your business. Then think about the capabilities that are out there and then choose wisely. There are many options. Not always the one that gets hyped up is the correct choice.
That's great advice. All right. Well, this has been Mainly AI. Manya, thank you so much for joining us today.
Thank you for having me.
Absolutely. If you like what you've heard, be sure to like and subscribe to our podcast. And until next time, this is Dan Mitchell with Mainly AI.
Thanks for listening to Mainly AI. Follow the show for more conversations about artificial intelligence and emerging technology. Until next time.